So I put x minus 1 times 3 minus 3x minus 1 times 1 over x minus 1 squared. I got it wrong.
Okay, let's start with some homework questions. So the most commonly missed, number 9 was first. Okay, let's talk about number 9. So number 9 is saying find the rate of change of x times f of x. And then what this means is, and then once you have the rate of change, evaluate the rate of change at 3. So we're finding rate of change functions, and so then what does that mean? It means at any point x, that function will tell you what the particular rate of change is for that x. So this is the rate of change of this particular function, and then once you have the rate of change function, find the particular value of the rate of change at 3. Okay, so what's the question we ask? We want to find the rate of change of that. So what's the question that we ask? It's the overall structure. What's the big picture? Tell me. It's a product. Okay, so our product rule is the first times rate of change of the second plus second times, so the rate of change of the first. What's the rate of change of x? It's 1. Okay, it's 1. So now we want to do this at x equals 3. So x equals 3. Times 1 is just f of 3. So this is 3 times. Your numbers would have been different, but f, the rate of change of 3 at 3 is 3. And the function value at 3 is 1. So my answer is 10. Okay, questions on this one? Anybody, does that clear it up for those who had trouble? Okay, next one is 10. So number 10, we want to find the rate of change of, I'll write it again. Overall structure. Olivia, what's the overall structure? What? A quotient, right? So our overall plan of attack will be to use quotient rule, right? Quotient rule. So our quotient rule, so if we call this, I think typically we call this F, and we call this G. Our quotient rule is, let's see, Lauren.
G times the rate of change of f.
Good.
Minus f times the ratio of g.
Uh-huh.
Over g.
So what we'll need is, we'll need the rate of change of F, first of all. How will we get the rate of change of F? Yeah, Autumn.
The product rule.
Product rule. Okay? And so quickly, that is the first times, I'm running out of room here, derivative of the second, plus the derivative of the first.
3 times.
Okay, so there's our, and then the rate of change of the denominator. Katie, can you do that? Rate of change of 1 plus cosine x. Anything else? Nope, that's it. Good. All right, so now we just, our overall plan, since this thing is a quotient, our overall plan is to apply the quotient rule. So we got, I'm just going to, so 1 plus cos x times that minus 3x sine x times negative sine x all over 1 plus cosine x quantity squared. Questions on this one? Number 10.
So if they're, like, if you have a x in front of sine or cosine, that is a completely different, that like it has it's a different number than sine x. It's not associated with sine x. Is that
What
correct?
is the structure of that function right there?
That's what I'm asking.
Yeah. What is the structure of it? Is it just sine?
I don't know.
No, because there's an x here. So you've got to see this as a function of x, and so is sine a function of x. So what's the structure?
So it's a product.
Product, right? If it were just 4 sine x, then it would just be the constant multiple rule, and basically sine. But if you have anything
Before
concerning, well, it's not before sine. This is a product of 2 functions of x. So I mean, what if it was cosine x times square root of x? What's the structure of that? It's a product. Yeah. Is it better? Other questions on this one? Okay, 12 through 15. We'll see. Let me just glance at those and see which ones we want to do. Okay, let's just talk about each one. So, what's the game plan for this one? Sharon?
It's power rule.
Power rule? Is that the overall structure? Yep. Power rule. And so power rule says 4 times something to the third. What's going to go here? X, that quotient, or the rate of change of that quotient? What will go in there? The quotient as it is, right? Okay, so that will just be that quotient. And then what? Chain rule, right? Because it's the power rule, but it's actually a function plugged into the power rule. So the overall structure is, yes, the power rule, but then we need the rate of change of that. And what will that be like? Quotient rule. Anybody have a question on that?
So then, once you get the quotient rule in there, you can just stop, right?
Yeah. Yeah, because that's all that thing is. Right there is the quotient. Yep. Any other questions on this one? Okay, next. Okay. Zoo. Overall structure. He wants product rule. Agree with that? Yeah, most people are not. Right, this is a product. Okay, so this right here is, call it F. Call this one G. So we'll have the product rule. Okay, when we get to the rate of change of F, Dan, what will that be?
The rate of change?
Yeah, the rate. So this is easy, right? F is, we already have it. G we already have. So all that's left is get the rate of change of G and the rate of change of F. So how will you approach the rate of change of F as part of the product rule?
You do the 4 in front of the parentheses and then the x minus 1 to the third power.
Uh-huh.
Then times just g.
Times g?
Yeah.
So is this the rate of change?
No, times 4.
Right, so then chain rule, right?
Yeah.
So within the product rule here, each of these rate of changes that we'll have, that whole thing is the rate of change of f. And then this will also be the chain rule. Let's have someone do that. Chelsea, can you do the rate of change of g?
G, 4, 2 minus x to the fifth.
Mm-hmm.
To the third.
Mm-hmm. So we're doing the rate of change of what's inside here. So just apply the rule again. What was the rate of change of negative x to the fifth? Negative 5 x to the fourth. Okay, so this is not the solution, right? You also have to multiply this one by f and this one by g. I just did the rate of change functions f and g rate of change. Questions on 13? Okay, yeah, let's do this last one. Okay, overall structure of this. Talia.
Product rule.
Yeah, for the most part. So before that, though, what's the overall structure? Yeah, so product definitely is the meat of this problem, okay? It's that. But really the overall structure of the whole thing is a sum, right? So so all the work concerns what you said, the product rule. But really we start by thinking of it as the rate of change of that plus the rate of change of that. What's the rate of change of 5? 0. Okay. So now we got f and g. So if we got product rule here, it's going to be all right, f is x. So rate of change of g, that's going to be the interesting one. Oh, sorry. I did the same thing twice. Easy to fix. Okay. What is the rate of change of f? Yeah? 1, right? So the rate of change of f is 1. So here's our product rule. All that's left to do is rate of change of g. Okay, how do we approach the rate of change of g? Corey, overall structure of that.
Product.
Okay, product. Is this times? It's of, right? It's tangent of that. So what is our overall structure? No. Chain rule, right? Tangent. Tangent's the overall structure with the chain rule. Okay? So, rate of change of tangent.
Secant squared.
Secant squared of? With respect to the plugged in function, then?
Times the square root of x.
Times the rate of change of that.
Does that just become the square root of x then? Or is it
Nope. It's going to be 8 times 1 over 2 square root of x. That was our rule for square root of x. And if you ever forget that rule, what can you do? Just do x to the 1, just change it to x to the 1/2 and do the power rule. We showed that that's the same thing. So if you ever forget that rule, it's also a power rule. So this right here is just this part of the product rule, the rate of change of g. So you'd have f, rate of change of g, which is this whole thing, plus g, rate of change of f, and then the whole thing plus 0.
You don't have to put the plus 0 there, right?
No. Okay. So that was the homework. Last chance questions on the homework. The mastery test is Monday. And I gave you the problems, your problems that will be on there. You will have 10 of these problems on your mastery exam.
Mastery exam only 10 problems.
What's that?
Mastery exam only 10 problems.
It's 10 plus a rapid fire of all the easy rules. Okay? So it's 10 of these, plus I'll show you in a second kind of an idea of what the other part of the exam is. Okay? So, but now some of these are we haven't covered yet. For instance, number 1, number 5, number 8. So I put the list on Blackboard. Okay? So look at that list. It's the ones that have an x in the base and the numerator, and the power, and the ones that aren't y equals something with x, so like an equation containing y's and x's. So anytime there's an equation of y's and x's like that, we haven't done that yet, so you can skip those. And anytime there's one where the x is something with x is in the base and something with x is in the exponent, also haven't gotten there yet.
So those won't be on the mastery.
Right. So those won't be on the mastery exam.
Will there be posted answers?
We were on.
Okay, so let's talk about that. So you have the tools to check these answers, and the tool is Graphing Calculator. So how can we'll do an example of that later. So hopefully, when I say that, based on your great conceptual understanding of everything we've talked about, you think, oh, of course, Graphing Calculator can help me do that graphically, can help me check these. So we'll talk about that in a minute. So let's do some of the rapid fire. What? Huh? So I'm just going to write a bunch up here, and you can take some time to see how these go. Okay, so with these traits, does everyone know that that is not 1 over tangent x? This is the... No, it's not that either. That's 1 over tangent x. This function is the inverse tangent function, inverse tangent. So it's which is also arctan, that's right.
This is too.
Did you say this is too many?
Yeah.
Are we gonna play
I'm just
bingo?
Yeah, I hope you're just kidding. No, we're not playing a game with this. I'm just writing them so I have room to put answers.
First column or down.
Okay, so practice these. We'll go over them in a second.
Oh wait, or is that one? Or is that the fourth root?
Keep a pen in this bag. Got an extra pen?
Yeah.
Thanks.
To like a number. I think we need to have something else. There's like a rule. Well, no, that would be. Yeah. There's just there's a rule.
That same function.
What is that inverse of sine?
I don't think that's right. Yeah.
Something over a square. I think it's negative 1 over a square.
Well, it's
So, because normally it's a square root of x, because that's 4.
Yeah.
So it's already it's 5. Yeah, that's 4. So that's what I did, I don't know. And it's got my negative. I mean,
So letters on the top, but just like
X.
it's the original. Times ln basically like EDX. Yeah, because
So
ln
you're saying, where did you do the one right before that?
so version of EDX is actually EDX ln lne is this one. So you just do EDX. So 3DX is 3DX ln. PyDX, PyDX.
Oh, or
Yeah. Wait, I think it's like
So take the cosine of that and then try to get a line up, it's gonna be over. So that it's
Cheat sheets, like the fifth or whatever.
it's gonna be 5 e to the fifth, but cosine of there's no variable.
Either the fifth,
Because now it's
it's
X.
my numbers.
Oh, yeah, now that you switch someplace.
yeah.
Okay, so it's like, so it's equal to
Ready?
minus 1.
X is
Is that you? Are you saying tell me that it's x cubed? Is that x cubed?
make sure
Oh, so next to
what
that.
is being raised is the constant to a variable or a variable to a
1/3.
Okay, sine of negative what?
Alright.
I really remember, I really can go through this whole process, but to find all the inverse transforms. But you have to make it right and label it, it's like,
There's a variable that's not
it's just yeah. But, there's a good way to refer
but
these.
it's these deeds that throws off.
Can't remember, you know. Oh,
Okay, just a couple more minutes. I'll come around if
all
you got
the
questions.
C's, they're all
Grab me if you got questions.
so only the ones that start with C are negative. the rest of them are positive, and then if you just line them up,
Now your x minus
cosecant, and then, you know what I mean, these are just, they're the same exact thing, but with the secant. So you have to write
When I wrote down like I first did like secret so I ended up trying to turn it up and I ended up worked out where
Yeah, it'll work. Everything right, and then you use your tree identities right, and you'll get the same answer. So it's a matter of different approach, but then tree identities. It should work, but it's a lot easier just to learn secant.
because that's
The function is the same tangent of that. Tangent is a function of phase input. This is the input into tangent. It's not multiplication. This is the same as
Yes.
Same as multiplication.
No, you went the wrong way.
You got some.
no, it doesn't keep back around.
One of your x's to the one.
That's what I did. He
The
did it.
original is x to the negative one, then your power. Dude, what do we got? We got 1 over x. If we do this, power will win. Or,
Well, then I gotta figure out where that is.
so, yeah.
If you make
Motion
it
will same way.
x to the minus 1, you minus 1 out
X,
front.
d high is 0, minus high, d
And then
low
it's
is
negative
1.
1.
Yeah, so it's
X
hard.
squared.
This is just negative 1.
It's not just tangent of beta, it's tangent of a function.
So,
So we know that's a function too.
How's off?
Oh, that was terrible.
My head hurts so bad. I'm feeling so much more. B4? Dang. I think you just did fractions wrong. What did you get? 1/3 over x to the. Oh! Because cube root of x is just x to the 1/3, just like cube square of x is x to the 1/3. So I changed it to 2x to the 1/3 and just power of 1. Then I got 1/3 out.
It said
I didn't like to retake
negative 1/3. You subtract 3 from the box of 1.
Yeah. So anything is 1/3. Yeah, 1/3. So
So then you subtract 3 from the top of
Yeah. Well, I'm saying like, we can bring it up and say here, we say x to the negative
x minus L.
where? At the beginning or after? I just didn't.
He gave us
I'm just saying, just to set it up, we got it the right way.
Oh, I just wrote 2x is 1/3.
Okay. So the 1/3.
Because the cube root means it's raising it to 1/3.
Hey, it's not x. For the log, log 1, it's not minus L.
Log 1 is 10.
Yes, that's the way I would do it. I would make it as powerful, and then use it. Absolutely.
Yep.
Questions on this side? No, that's the master. So I give it to you. That's all 30 on the master test.
So,
On that you can't take that sheet in.
That's right.
Yes.
That's a bonus.
Just write it down like 8 times.
I wanted to say like, so I kind of
Two. C3 or D3?
Yeah, that's a
Cosine of constant is still like
X to the 1
Okay, let's do some of these. Which one should we do?
All of them. 1 over the
rapid fire.
the fourth root of X squared.
All right, let's do that one.
If you get it wrong, you get a shot.
Okay, here we go. So, Dan, what'd you do for this one?
I made it into power rule. So I did x to the negative 5/4.
Is that what that is? Not the rate of change, but the original function itself. Is that x to the negative 5/4? Okay, so from there,
Just use the power rule.
Okay.
I brought negative 5/4 down
good.
and subtracted 1 from the power, which is I think negative 1/4.
So closer to 0? We're going 1 closer to 0, or are we subtracting 1? What are we doing?
Oh, adding, so subtracting, so it's going higher or negative.
Okay, so if we're truly going to subtract 1 from the old exponent, so what do we get? 9/4. So you could try to do quotient rule on this, but it'll take you a long time. Okay, and you'll get the same thing, but this is a lot easier way to do this. Change it to just a basic monomial to a power first, which is x to the negative 5/4. Negative because it's in the denominator, 5 because that's the power, 4 because it's the root. And then just apply the power rule. Questions on that one? Okay, another one. How about e pi to the minus 2? Negative 2 pi to the minus 3. What is it? 0. That is a number. That's not a function of x. That's a number. So what's the rate of change of a constant value? How fast is a constant value changing? It's not, right? So it's 0, right? It's constant no matter what you put in for x. There's no change. So the rate of change, or the speed at which it's changing, is 0. Okay, another one. So these are just rules. E to the 9th. 9e to the 8th. No, it's e function. E to the 9th. 0. Okay. 1 over x. Natural log of x. No, you got it reversed. The rate of change of ln of x is, that's 1 over x. But the rate of change of 1 over x is not ln of x. So you're going to start by making it x to the minus 1 first, and then negative x to the negative 2. Don't recommend it. Yeah, you could do quotient rule.
I mean, you can just do it in your head real quick, because it's a simple function.
Be my guest.
Okay.
Okay, what else do we want to do? X to the e. What is the structure of that? Is it an exponential function, a power function, or a constant? It's a power, right? It's x is in the base with this numerical exponent. So its power rule is e x to the minus 1.
What about an exponential? So like 3 to the x?
3 to the x. 3 to the x. So remember that day that we worked on, we said that exponential functions, the rate of change is the original function times some constant. Remember when we used the graphs to find what that constant was? And it turned out to be the natural log of the base. Cosine of e. Negative sine of e. E is a number, so we're plugging a number into cosine, and we're going to get another number. So the rate of change? 0. How about pi to the x? So what kind of function is it? What's the structure? Exponential function, right. So the rate of change is? Pi to the x, natural log of pi. Negative 50x. Negative 50. Negative 50. So a linear function, if you're asking about the rate of change of a linear function, what's the rate of change of a linear function? The slope of it, right? The slope of it. So that's one way you can think of that. The slope of this line is negative 50. That's describing the rate of change, how fast y is changing relative to x. Negative 50 times as fast as x changes. Any other requests on these?
2 times 3
Okay, what are you going to do first? 2 times x to the? So Corey, what would it be?
So then from there it's 1/3, so it's 2/3 x raised to the 1 minus, or the 1/3 minus 1.
Right. Any more requests? Yeah, Adelaide. ln of 8. Well, ln of 8 is not 0. The rate of change. The rate of change. That's another constant. Watch out for constants, right? This is not, the rate of change is not 1/8. What function has a rate of change of 1/8? What function has a rate of change of 1/8? 1/8 x, right? 1/8 x. So this is just a number. It doesn't change as x changes, so the rate of change is 0. What's that? That's inverse sine or arc sine. That's one of your rules on the sheet I just gave you. Okay, let's do it. So let's talk about. You have all these that you're going to be practicing over the weekend. Some of them will be on your exam. So let's talk about how you can check, because I'm not giving you an answer key. So how can you check using graphing calculator? So let's do this one here.
Thank you.
That is an integer. I don't understand.
Significant digits, maybe?
Oh, precision. That's not what I want. I want to change this. Okay. All right, so we came up with a rate of change of negative 5/4 x to the negative 9/4. So sure, we can graph that. So what was the original function? X to the minus 5/4. So we can graph that. So does that tell us if it's right? Does it tell us if our answer is right? So everyone think, how can we use graphing calculator to confirm that this is the right closed form rule for the function x to the negative 5/4?
Use the open rule function with the slider set to h.
Are you saying something about the open rule? Is that a hand? Yeah.
Yeah, perhaps take the integral and see if it equals the original function.
How about we graph the original function?
Yeah, that might work, Daniel. Wasn't what I was thinking. So the original function, if we graph the original function, we might be able to kind of see if it looks kind of generally right, but we still don't know exactly if that is exactly right. So, is it Connor? Are you having a suggestion there?
Oh yeah, I was gonna say just use the open form, which is like the f of x plus h minus f of x over h, and then use the slider
Okay, so
Make it approach, like pretty much approach your infinity. I'm sorry, you can make h approach 0, and then it can be a differential.
okay, so take your original function, make it f, and then what could we graph relative to f to check to see if our closed form rule that we came up with algebraically is correct? What could we graph? Did you hear what he said? DJ.
Oh, yeah, it's
When we describe what he said, like the f of x
So
plus
tell me what to type.
So f of x plus h minus f of x. Now it's all gonna be divided by h, and then we'll create a slider for the h value and make it
Don't even need a slider. Just call h.
0.0000.
Yeah, just enough zeros to see. Okay? So I've got, so this is our rate of change, right? This is our rate of change for sufficiently small h. This is our rate of change function. All this work that we're doing is to come up with quick rules. But this is, when you think of a rate of change function, this is what your image of it should be. And then we have all these rules to come up with them quickly. So we can use graph and calculator, and what should happen? So here's our, what we came up with algebraically, the pink one. And now if I graph the rate of change, it should be right on top of it for a small enough h. So yeah, if we make h 0.5,
not bad.
right? But if we make h nice and small, so this is how you can practice checking all those ones that you work on over the weekend. You graph the rule that you come up with, and then graph the open form for the function you started with. Okay, so let's have you do 2 more. So these are hard ones, like on your quiz today, and like the similar to the ones you'll be working on. Where does the time go?
Can't ever cheat sheet on the quiz today either.
Nope. Oh yeah, the one I gave you?
Yeah.
Sure, you can have that for the quiz.
Okay. I was like,
But
got a lot
not
of memorization.
not for the mastery.
Oh, word?
Is that like the second problem?
2 problems.
Okay.
Why don't you write these down, work on them between now and recitation, and you can start recitation by doing these 2, and then you'll do your quiz. Okay? I'm sorry? Today's quiz, not the mastery exam. So for the mastery exam, you can't have it. You can use that for this weekend and for the quiz today. Yeah.
Are we gonna go over this type of stuff on Monday? Like, is it smart to wait till after class to take the mastery exam on Monday, or?
No, we're going to start new material.
Okay.
So if you're feeling confident and you want to go in the morning,
The testing center doesn't open until 10.
yeah, it doesn't open until 10:30 anyway. Yeah, so gonna have to be after class. Okay, so write these down. Work on them before recitation. Log base 7. Log base 7 of 5x. So
And that's tangent, right? Plus 3 tangent of.
inverse tangent.
Okay.
Inverse tangent. Secant inverse.
I just couldn't see what tangent.
TAN. Yeah. Inverse tangent.